All right, hello AP Stats students. Sorry I missed our online meeting today. I got sidetracked doing something else, and when I looked up, it was like 1:08, and I was like, oh no, I totally blew it. So I apologize. So this is what I would have gone over with you in class, so I wanted to show this to you. First of all, I guess before we mention this, the homework for today, Friday, is to do that Scrabble review. And if you go into the homework assignment, there'll be links for our class, and you should click on the link for the data for 6th hour, and then you'll get a list of our data. Then use that information to do the homework assignment. And then you can upload a picture of what you did, or you could make a copy of the worksheet and type stuff in and then upload it, however you want to answer those questions. Also, don't forget that you have the Unit 2 quiz that is due Sunday at midnight, okay? Now, it's not going to turn off Sunday at midnight, but on Monday we'll put in zeros for kids that haven't taken it yet, and you can obviously take the quiz to get rid of those, but let's try to do those, get that quiz done as quickly as we can. Next week, we'll just be reviewing for this test on Unit 2, and the test will be assigned over the following weekend, okay? So, what I was going to show you today was R squared, okay? And just kind of talk about what R squared means. So here is actually your 6-period Scrabble scores in this little chart here. And you can see the letters in people's names. And you can see the score for their names. And the table isn't complete. I think we had 23 or 24 people participate. So you can see that in the table. And then the third column, I just threw in a 1 through whatever and numbered you guys off so that each of you have a separate number. And then think about this. The whole goal of this unit is that we have 2 variables that we think are related, and we hope to be able to use one variable to help us predict the other, okay? So I'm going to zoom in on this first graph here. This is a graph of the Scrabble scores for everybody that participated as the Y value of these points. And then the X values are just the numbers that I numbered you guys off as. So they don't mean anything. They have nothing to do with the scores. They're just the alphabetical list of your names. So you can see the scores for Scrabble are scattered around. And if I wanted to use those scores to predict someone else's Scrabble score, okay, based on their first name, the only real thing I could do is take the average of all of those scores, because all I have are those scores to go by. So down here, I have that the average score for those 23 people or 24 people was 10.9, and I put that blue line on the graph. So if someone came up to me and said, hey, can you predict my Scrabble score, and they weren't in this class, my best guess would be to say, I'm going to guess 10.9 is your score. It's just the average of all the scores that I've ever gotten, okay? And obviously at this point, I don't know what their names, like how many letters were in anyone's names, okay? But obviously that's not going to be a super good way to make a prediction, because if you look at the graph, I'm only going to be right, or that graph only would have been right for 4 people. Everybody else I would have been wrong for. Okay, so there would be some error in my guesses. And one way to quantify that error, if I wanted to figure out like how much error there is I could find all the residual values. So I'm drawing those in. And if I added up all those residuals, the problem is they would cancel each other out, and I would get 0. So adding them up doesn't help me find out how much variation or how much error there is in making this prediction. So what I could do is, I'm going to slide to the next picture, is instead of adding up the residuals, I'm going to square all the residuals. So you can see like this is the original residual, and then if I square it, I get a square. Okay, and what squaring all those residuals will do is it'll make the negative ones positive. So now if I add up all those squares, they won't cancel out, okay? And if you see at the bottom here, I have the sum of the squares is 501.8. So you could think of this as there's 501.8 units of variation in Scrabble scores, okay? You could also think of it as kind of like the error in my guesses, okay? Like if I guess somebody's Scrabble score, there's going to be error involved. I'm not going to be right very often, okay? So that 501.8 is the total amount of error I have. Now, let's say I want to use the letters in your name to try to make a better prediction of your Scrabble score. So now this graph, in the bottom left, this is using the letters in your first name as the X variable and your Scrabble scores as the Y variable, okay? And then I put in the regression line. So one thing I'd like to know is it a better way to make a prediction to like know how many letters are in your first name and then try to predict your score, or is it better just to use the average? Okay. Well, so I'd like to know like how much error or how much variation is there in my answers now. So again, I could, come up with all the residuals, but again, those are going to cancel each other out. Okay. Some of these are in the same spot. So what I do, again, is we square those residuals, okay? So I end up with all those squares, and then I find the sum of them again. So now I have 327.2 units of variation, where before I had 501.8. So I've actually done better, right? I've reduced the variation or the error in my guesses, okay? So by knowing how many letters are in your first name, like if you tell me 7, I can make a better prediction now of your Scrabble score than I could if I just guessed the average, okay? So how much better is my guess? Well, let's figure out how much error I have removed, or how much variation I have removed from the process. So what I would do is take 501.8, my original error, and subtract the 327.2. And I get 174.6. So that's how much error I have removed from the problem, okay? So it might be interesting to know, like from a percentage standpoint, how much of the variation have I removed from the problem? So I could take that 174.6 and divide it by 501.8. That was my original amount of variation. And if you do that, you get 0.35. And if you look at our information here, that is exactly the same as r squared. So what r squared tells us is how much of the variation have I taken care of by including the letters in my regression, okay? So I've removed 35% of the variation. So this is how we would interpret that. We would say 35% of the variation in Scrabble scores can be explained by the regression with letters in your name. Okay, so that's r squared. It's the percent of the variation in Scrabble scores that can be explained by the regression with the letters in your name. Okay, so basically I've removed 35% of the variation by doing a regression with scores and letters. So I do a 35% better job of making predictions than if I just use the average all by itself. Okay, and in AP Stats, what you really have to do is memorize this statement, that it's r squared is the percent of the variation in the y values that is explained by the regression on the x values, okay? And they will literally use that word variation, okay? So that's the key word you're looking at. On the AP test, oftentimes the r squared questions are in the multiple choice. So they would maybe give you the r value and then say, one of the choices would be like 35% of the variation in blah, blah, blah is explained by blah, blah, blah. And so you'd have to pick that answer out of a multiple choice situation. And I have to tell you, this topic, I've taught this class for over 20 years, and I didn't really understand it the first few years I taught it. Like it was, I really was just teaching the kids how to memorize the answer. And then we went to a conference on statistics, and someone came up with this kind of explanation, and then from that moment on, it made sense. But it's funny, almost every stats teacher you talk to, I'd say about half of them really understand what this is about. So if you understand this, that's fantastic. If it's a little confusing, realize that a lot of stats teachers don't even understand how to really explain this. What I would do if I were you is I would go back now and watch the video for this lesson, the R squared lesson. And hopefully after watching that and this, it'll start to make sense for you, we hope. But it's a tricky topic, okay? So again, I'm super sorry that I came late to the meeting. I'm gonna have to start studying my Alexa, that it reminds me. I have 2 kids at home that I'm trying to help with their homework, and it's super easy to get distracted and kind of off track. So I apologize again, but good luck with this. And if you have any questions, please email me, even over the weekend. And remember, don't forget to take that quiz. Thanks.